we live in a world that was literally built by heroes. But these heroes, you've probably never heard of them. They didn't carry swords. No, they carried genius and grit and just the raw stuff of the earth. So in this explainer, we're going to pull back the curtain on the world's first great engineers. These are the original problem solvers, the ones who basically laid the foundation for, well, everything.
Okay, so look at this. On one side, you've got the Great Pyramid. It's been standing for over 4,500 years. And on the other, the Brooklyn Bridge, a total icon of our modern world. I mean, they seem like they're from different planets, right? But what if I told you they're connected? That there's this unbroken line of knowledge stretching between them? Yeah, the very same kind of genius that figured out how to hang steel cables over a river. Well, its story starts with stacking stones in a desert. So let's dive in and find out how.
I mean, just stop and think about it for a second. Without engineers, there's no phone in your hand, no roof over your head, no clean water coming out of your tap. They are the ultimate unsung heroes, right? The brains that literally shape the world we live in. And their story, it goes all the way back to the very beginning. You know, Adam Hart Davis, who's the editor of our source material here, he just nails it. He says, engineers have always been heroes of mine. And he's so right. Because these folks, they weren't just builders. No way. They were pioneers. They were leaders. They took on these massive projects and shaped the world with their vision. So that's exactly how we're going to treat them, like the heroes they absolutely were. All right, so for this explainer, we're going to focus on 3 of the absolute earliest and most brilliant minds. We're talking Imhotep in ancient Egypt, Eupalinos over in Greece, and Sostratus in Alexandria. I mean, their work covers thousands of years, but you're going to see it's all tied together by one single, really powerful idea. Okay, so let's kick things off at the very beginning. We're starting with a guy who basically invented the pyramid and kicked off the entire age of stone architecture. His name was Imhotep. So here's the challenge, and it is a huge one. The pharaoh, Djoser, he wants a tomb that will last for eternity, forever. But what are the tools they have to work with? Well, they're super basic. We're talking stone pounders, some copper saws, and wooden rollers. That's it. So how in the world did Imhotep pull this off? Well, first thing you need? An absolute genius. And Imhotep was way more than just an engineer. His official titles included Chief Sculptor and, this is the big one, Royal Seal Bearer. That's one of the highest jobs in the entire kingdom. So this guy had some serious power and an incredible mind. And the scale of what he was planning, it's just staggering. We're talking 11 million cubic feet of stone. To put that in perspective, that's enough to fill almost 130 Olympic-sized swimming pools. And you have to remember, this was the very first time anyone had ever even tried to build something this huge entirely out of stone. Wild. But here's where his true genius really shines. It wasn't just about the final product. It was about the process. See, Imhotep didn't just have this perfect plan from day one. Nope. He iterated. He experimented. He started with a traditional flat-top tomb, a mastaba. Then he thought, what if we add another layer, and another, and another? He was literally inventing as he went, creating not just a tomb, but what was basically the world's first skyscraper. I mean, his legacy is just immense. He's the first engineer we know by name in all of history. And get this, underneath the pyramid, he designed this incredible underground complex with nearly 3.5 miles of tunnels. He was so respected, so revered, that centuries later, the Egyptians actually worshipped him as a god of wisdom. Just think about that for a second. He is the only engineer in history to ever become a god. That's incredible. So Imhotep totally mastered building up, right? Reaching for the sky. But fast forward about 2,000 years, we're on the Greek island of Samos now, and our next hero is facing the exact opposite challenge. He had to tunnel through the earth to solve a problem that seemed just as impossible. Here's the situation. The city of Samos desperately needed a secure water supply, one that enemies couldn't just cut off during a siege. The only solution? Dig a tunnel straight through a mountain, Mount Castro. But the craziest part of the plan, the most audacious part, was this. They wanted 2 teams to start digging from opposite sides and meet perfectly in the middle. I mean, how on earth could you pull that off back then? And yet, they did it. It took 10 years of digging with nothing but simple hammers and picks, but the 2 tunnels met,
And the margin of error? Get this, just a 2-foot difference in height. That is an absolutely astonishing feat of precision. Nothing would come close to that for centuries. Now, this wasn't just luck, it was pure math. Eubulinus and his team used practical geometry, probably using simple sighting tools and water levels, to plot a perfectly straight line through solid rock. And here's a really cool historical twist for you. The very same island, Samos, was the birthplace of Pythagoras. Yep, that Pythagoras. The guy who would later write down the formal proofs for the geometric theorems that made this impossible tunnel possible in the first place. All right, for our third hero, Sostratus of Cnidus, we're heading to Alexandria. At the time, this was the intellectual and commercial capital of the entire ancient world. And here, the challenge was all about light and massive scale. So Alexandria was this bustling, thriving city, right? But its harbor was actually pretty tough to navigate. So what the city really needed was a landmark, a giant beacon that sailors could see from miles and miles out at sea, guiding their ships safely into port, no matter if it was day or night. And the solution was this. The Pharaohs of Alexandria. We're talking about a building around 400 feet tall, making it the second tallest structure in the world at the time, right after the Great Pyramid. It was one of the 7 wonders of the ancient world, and it was, for all intents and purposes, the planet's first great lighthouse. And if you want to understand just how important this thing was, just look at the price tag. 800 talents. That was 1/10 of the entire royal treasury. This wasn't just a building project, it was a massive national investment. That's how vital this piece of engineering was for the city's survival and its future. A poet from the time described it perfectly. He said that during the day, a giant bronze mirror would reflect the sun's light for miles. And at night, a huge fire would be blazing at the very top, a flame so bright you could see it from almost 20 miles away. It was a constant promise of safety, of a safe harbor. Okay, so let's recap. We have a pyramid, a tunnel, and a lighthouse. 3 absolutely incredible projects, but all very different. So what's the common thread? What's the secret code that connects all great engineering, then and now? Well, for that answer, we've got to turn to the Romans. Let me introduce you to Vitruvius. This guy was a Roman engineer who served with Julius Caesar himself, and he was the first person to actually sit down and write out the rules, the secret sauce, if you will. In his book on architecture, he basically boiled down the essence of what makes a structure not just functional, but what makes it last and what makes it truly great. And here it is, the timeless code that connects every single one of these great engineers. Vitruvius said that any great design, any great work, has to have 3 things. First, firmitas, strength. It has to be strong, built to last. Second, utilitas, utility. It has to be useful, it has to do its job. And third, venustas, beauty. It has to look good, to delight the people who see it. Strength, utility, and beauty. That is the code. That's the unbroken chain connecting every hero we've talked about today. It's what guided Imhotep's pyramid, Eubulinus' tunnel, and Sostratus' lighthouse. And it's the very same spirit, the same exact principles, that connect a simple Roman crane to the incredible soaring ironwork of the Eiffel Tower. It's a direct line, right through human history. And that, of course, brings us to today. The materials are different now, and the challenges have definitely changed. We're not wrestling with stone and water anymore. Now it's about climate and energy and data. But the need for those heroes, for engineers with that same vision, to build a world that is stronger, more useful, and more beautiful, that need has never, ever been greater. So the final question is, who will they be?